Our subject is digital signal processing. In this lecture, we are going to discuss about decimation in time fast Fourier transform. So, from this lecture, the students can able to apply DIT FFT algorithm to calculate the discrete Fourier transform of any sequence. Generally, DIT FFT stands for decimation in time fast Fourier transform. So, the decimation in time fast Fourier transform are the simplest FFT algorithm. So, in direct computation of DFT, it takes more time for the computation of discrete Fourier transform. So, it will take more time. So, here we are using FFT algorithm. This is the fast Fourier algorithm. It uses the symmetry and periodicity properties of Twiddle factor. So, it will effectively reduce the DFT computation time. So, next, this is the basic butterfly diagram or flow graph. So, for the calculation of DIT FFT radix 2 algorithm, we are using this flow graph. So, here we have the two complex number A and B. So, this complex number B is multiplied with the Twiddle factor W n power k, and this product, that means B into W n power k, is added with a complex number A, and it gives a new complex number capital A. So, the capital A equal to A plus B into W n power k. And here this product B into W n power k is subtracted from complex number A, and it will form new complex number B. B equal to A minus B W n power k. So, this is the basic computation of the signal flow graph. That means the butterfly diagram. So, in radix 2 FFT, n by 2 butterflies are used in per stage. Per stage we are using n by 2 butterflies to represent the computational process. So, here we have the procedure. First step, determine the length of FFT. That means n. N is the length of FFT. So, it may be 4, 8, so anything. So, step 2, calculate the Twiddle factors. Then step 3, we have to decimate the input sequence in a bit reversed process. Next, step 4, we have to plot the flow graph for first stage. Step 5, calculate the first stage output, and step 6, we have to plot the flow graph for second stage and calculate the second stage, and step 8, summarizing all FFTs. So, now we are going to explain one example. So, here the calculate DFT for sequence x of n 1, 0, 1, 0 using 4-point DIT FFT algorithm. Okay. So, in this problem, the given data, so x of n equal to 1, 0, 1, 0. So, here we can take, this is the first sequence, x of 0 equal to 1 and x of 1 equal to 0, next x of 2 equal to 1 and x of 3 equal to 0. So, in this problem, determine the length of FFT. So, here we have 4 sequence. So, we have to consider the length n equal to 4. Step 2, calculate the Twiddle factors. So, here for the 4-point DFT, we have 2 Twiddle factors. So, normally we know the expression for the Twiddle factor W n power k equal to e power minus j 2 pi k divided by n. Here we have two twiddle factors. So we have the value k equal to 0 and k equal to 1. K equal to 1. This is not 2, it will be 1. Okay, so next we have n equal to 4. So W 4 power 0 equal to e power minus j 2 pi 0 divided by 4. So e power 0 value 1. Next we have the k value 1 because for 4-point DFT we have only two twiddle factors. So we have to substitute k equal to 0 and k equal to 1. And we know the value of n equal to 4. So W 4 power 1 equal to e power minus j 2 pi. Instead of k we are writing 1. 1 by 4, finally you have e power minus j by 2. So we can write e power minus j by 2 cos by 2 minus j into sin by 2. So you will get minus j. Next, third step, decimate the input sequence in a bit reversed process. So for DIT, third step, decimate the input sequence in a bit reversed process. So here input bit index 0, 1, 2, 3. So we have 4-point sequence, 4 point. So we have to start from 0, 0, 1, 2 and 3. Next, binary of bit index. So here 0 is represented with the binary number 0, 0 and 1 is represented with the binary number 0, 1 and 2 is represented with the binary number 1, 0. Like this 3, 1, 1. And next you have to write bit reversed. So bit reversed means here 0, 0 is reversed means 0, 0. But here 0, 1 that will be reversed means 1, 0. And here 1, 0. So if it reversed means 0, 1. Here 1, 1 means it will be 1, 1. So bit reversed index means 0, 0 value 0 and 1, 0 value 2, 0, 1 value 1, again 1, 1 value 3. So this is the bit reversed index. If you are writing in the first stage of computation, you have to write like this 0, 2, 1 and 3. So next step, plotting a flow graph for first stage and calculating the first stage output. So this is the basic flow graph or butterfly structure. Okay, so already I have discussed the basic operation, basic computation of this butterfly structure. So now we are writing the input sequence in the bit reversed order. So x of 0 equal to 1 and x of 2 value 1, x of 1 value 0 and x of 3 value 0. Next, in the bottom of the signal flow graph, we are writing the twiddle factor. W 4 power 0 equal to 1 and W 4 power 0 equal to 1. In the first stage of computation, we have to write the first twiddle factor. So W 4 power 0 equal to 1 and W 4 power 0 equal to 1. And in the bottom line of the flow graph, we have minus sign. So here also we have minus 1. Okay. So next, at the end of this flow graph, we have the adder. So here this 1 flows to here. And in this adder, it receives the signal from x of 2. So this 1 goes here. So 1 plus 1 we will get 2. And in this adder, where the 1 goes here. And this value 1 is multiplied with twiddle factor, that value will be 1. Again it will be multiplied with -1, that value -1. Next, in the adder it receives the signal 1 from here and -1. So when you are adding these two values, you will get 0. Next, here in this adder it receives the signal 0 and it also receives the signal from here. So this 0 is multiplied with twiddle factor 1. So you will get 0. And here 0 plus 0, finally the answer will be 0. Next, here in this adder it receives the signal 0. Next, this signal, that will be 0, is multiplied with -1. So you will get 0. After adding this value, finally we will get 0. So this is the output of the first stage. 2, 0, 0 and 0. This output of first stage is given to the input of the second input for the second stage. So here this is the second stage. Plotting of flow graph for second stage. Now we are going to plot the flow graph for second stage. So these are the output of the first stage is given to the input for the second stage. So the second stage butterfly diagram or flow graph, it will be some bigger than the first stage. Here for the second stage we have two twiddle factors. So W4 power 0 equal to 1 and W4 power 1 equal to -j. So these two twiddle factors already we have calculated. W4 power 0 equal to 1 and W4 power 1 equal to -j. You have to write in this place. Next, these two bottom lines have minus sign, -1. So next here, this adder receives the signal from here 2 and it also receives the signal 0 and 1 multiplied. So the answer will be 0. So 2 here in the adder we are adding two signals, 2 plus 0. So finally you will get true. And this adder receives 0 and it receives the product of 0 and -j, finally 0. Adds these two values, we will get 0. And here, so it receives 2 and 0 is multiplied with twiddle factor 1. So finally 0 and multiplied with 1, that value will be 0. Next, this 0 is multiplied with -1, finally this value 0. Here in the adder we are adding these two values, 2 plus 0 equal to 2. And here with this adder it receives 0 and it receives 0. It's a product of 0 and -j, 0. Again it is multiplied with -1, finally 0. So this is x of 3. So it is the DFT of the sequence. So x of 0 equal to 2, x of 1 equal to 0, x of 2 equal to 2, x of 3 equal to 0. Okay, thank you.